Gypsum is quite different from most other bulk materials that you may have had experience with. It's very fine and requires some learning on how to handle it, but once you figure it out, it's really not difficult. Some of the models commonly used to spread gypsum are those that are designed to handle bulk materials such as BBI, Chandler, and New Leader. These are designed with wide chains and steep sides to help the material flow more smoothly through them. Some spreaders are set up with additional equipment here, and this has to be removed before we spread gypsum. Now that we've removed it, you can see that we have a much more open area here for the material to flow, which is very important. We need to have the material flowing off the belt, unrestricted onto the fans. As you can see, gypsum is a very fine material, and as it flows off of the belt onto the fan and hits the blade, it's going to remain on the blade for just a little bit longer than if it was a granular. And therefore, as it comes around, it's going to be placing more on the outer edges of the pattern. So what we want to do here is we want to push this deflector so that it drops the gypsum sooner on the blade, so that when it begins to release, it releases in the center of the spread pattern. We have a more uniform pattern. Our goal is to control when the material drops onto the spinners. Some units are set up that the guide assembly moves and allows the material to flow where you want it to. Others are set up where the entire spinner assembly moves. Okay? So our goal here with this particular one is set up so that the guide assembly moves. What we want to do is we want to unlatch it on both ends and move the unit forward, which allows the material to fall on the spinners sooner. This is another unit, and as you can see, it has additional equipment here for other products. This would also be removed. And then once it is, the material will fall from the belt directly onto the spinner assembly. In this case, the entire spinner assembly is adjustable. And so what we want to do is we want to adjust this spinner assembly so that the gypsum drops on the spinners sooner. And so we would do that with this adjustment here. In this case, for gypsum, farther back, okay? For fertilizers, we want to move it forward. This is a unit that's set up perfectly for gypsum. As you can see, it's stainless steel. It's got slick, steep sides and a wide belt. But in addition, it also does not have the assembly for the shield over the belt. So we have nothing in the interior here that's going to cause any kind of bridging with gypsum at any time. We'll be applying gypsum typically at 1 ton to 2 tons per acre. So there's going to be a large amount flowing underneath of this door. And our goal here is to have the material flowing in such a way that it flows uniformly onto the spinners. If the door opening is too wide, it will come out in chunks and it will have pulsation in terms of the spreading pattern will be very, very non-uniform. So we'll want to have the door low enough that we get a constant flow. So what this means is if you're driving your spreader at 10 miles an hour or less, that door opening is probably going to be lower so that the material coming through is at a lower level, shorter in height, and ultimately flowing onto the belt. But if you're driving 21 miles an hour and putting on a ton per acre, you're going to have the door much farther open, and it will flow off and come onto the spinners and still give us a uniform pattern. So the door height is very important. It's really driven by the rate of the gypsum as well as the speed of the applicator. Here we have another bed, a different setup. As you can see, this is stainless steel, but it's painted. And unfortunately, gypsum sticks to paint, so it tends to want to hang up on the sides. In addition to that, as you can see, we have a very large shield here that is over the belt, and it's close enough to the belt that gypsum will actually bridge as a result of having this shield here. So if the gypsum, in this case, when we spread, it was raining, it tended to be more difficult to use, but the combination of the painted sides and the shield has created an issue here where we get a lot of bridging and we just don't get the flow of the gypsum that we need down onto the belt. It's best to store gypsum inside, out of the elements, but if that's not possible, you can store it outside. Whether you're stockpiling gypsum at the farmstead or out in the field, it's best to stockpile it at least 200 feet away from the nearest drainage channel. Most of these machines have electronic controls. And the bulk density of the material is programmed in. The spreader width, the speed, the application rate, all these things are programmed into this. So initially it's going to take a little bit of trial and error to get the rate down correctly, but once you have it there and it's recorded, it's pretty much a constant for that particular machine that you can use year in and year out.